This is our final example for Unit 14. And let's just read the situation here to ourselves. The farmer needs to build another pen. So he's already built 2 rectangular pens in the previous 2 questions. It must have an area of 16 meters squared. To save money, he wants to use the least amount of fencing possible. What dimensions should the pen have so it has the smallest perimeter? Now remember, when it's asking us for dimensions, we want the length and the width. And what makes this question different is, first off, we are trying to find the perimeter of this thing. So we're given the area, and we're trying to find the perimeter. In the other questions, we were given the perimeter, and we were trying to find the area. And we also want the smallest possible perimeter instead of the largest possible area, which is what we were doing in the other questions. Okay? So we're still going to be building rectangles here. Okay? So I've listed in this table what the area is going to be. The area is going to be 16 meters squared. We're told that in the question. And we can complete the table the same way we did before. We can choose numbers for the width and then figure out what the length is going to have to be. But because we're working with rectangles, we know that the area is going to be length times width. So if we know what the width is already, we can rearrange this thing to solve for the length. If I divide both sides by W, I get that the length is going to be the area divided by the width. So in our first line here, we've got an area of 16. If we want to figure out what the length is, we do area divided by width. So my length is going to have to be 16. Yes, because width times length, or 1 times 16, gives me 16. For my next one, I'm going to have to do 16 divided by 2, which is going to give me 8. Because a length of 8 times a width of 2 is going to give me my area of 16. So what calculation do I do for the third one here? Riley? Yeah, exactly. Which is going to give me a length of 4. And then down here, I've got to do 16 divided by 8, which is going to give me a length of 2. And for my final one, I have to do 16 divided by 16, which is going to give me a length of 1. Now notice, we don't have the same sort of pattern that we had in the other ones. Here, this is going up up by 1, then it goes up by 2, then it goes up by 4, then it goes up by 8. So in the previous questions, it was always, it goes up by 1 and the other one goes down by 1. Okay, so we don't have the nice regular pattern here. Now what we want to find is we want to find the perimeter that each of these rectangles is going to have. So our perimeter is 2 lengths plus 2 widths, okay, because we still have this a rectangle, which has 2 lengths and 2 widths. So we're going to fill in these columns here. We're going to fill this one in with 2 times our width. So that's going to be 2, 4, 8. When our width is 8, we're going to have 16. And when our width is 16, 2 times that is 32. And in this column, we're going to have 2 times our length. So 2 times 16 is 32. 2 times our next length is 8 is going to give us 16. 2 times 4 is going to give us 8, and so on and so on. So 2 times 2 will be 4, and then 2 times 1 will be 2. And then we just have to add up this column and this column to get our perimeter. So 2 plus 32 gives us 34. 4 plus 16 gives us 20. And we just fill in the rest of this just by adding those numbers up. Now, what trend do we see in this last column? What are these numbers doing as we start at the top and go down? Yeah, it's going down in the beginning and then it hits the middle and then it goes back up. So this is different than what we saw before. In the previous questions it increased and then decreased. Here it decreases and then it increases again. But let's answer these questions here. For the rectangle with minimum perimeter. Okay, which one has our minimum perimeter here? Yeah, the 16. This is our minimum perimeter. And what we're interested in are the length and the width. So what are the dimensions, length and width, and the perimeter? Well, our perimeter is 16 meters. Our length is 4 meters. And our width is 4 meters. What kind of a shape is this? 4 meters, 4 meters. This is a square. Okay? So whenever you're trying to make the smallest perimeter for a given area, you want to make your rectangle as close to a square as possible. So let's sort of apply that here. Predict the dimensions and the minimum perimeter of a rectangle with an area of 100 meters squared. So if our area is 100 meters squared, and we want to make this a square, okay, our length and our width have to be the same thing. So what are our length and our width going to be? Not 25, because then 25 times 25 would give us some really big number. What times itself gives us 100? Yeah, if we make our, and I'll do an arrow here, if we make our length equal to 10 and our width equal to 10, okay, they're the same thing. We get a square with area of 100 meters squared. So our square is going to look like this. 10 meters, 10 meters. What is our perimeter going to be of this square that I've just drawn there? So how do we find the perimeter of that thing? Remember, perimeter is distance around the outside. So we've got 4 sides, each of them 10 meters. What do we got to do? Yeah, we can do 4 times 10 meters, 40 meters. And that would be our perimeter. Okay? And we're done.